Prior to coming to Algebra 2, you thought there was only things called real numbers. You didn't know that you could do something like take the square root of a negative. And we expanded your mind to the complex number system so that the square root of -4 is defined as the square root of +4 times the square root of -1, thus giving us 2i. So the first essential standard is operations with complex numbers. There are 4 operations in math: add, subtract, multiply, divide. We also introduce you to the idea of something called the conjugate. You learned back in Algebra 1, if you had something like 2 over 7 minus root 3, that you weren't allowed to what? Leave a radical in the denominator. And so the same thing happens with imaginary numbers because they are radicals. So this is not your problem. Your problem is more something like 2 minus 3i over 5 plus 4i. And you need to simplify that. The key to doing this is understanding that there is a pattern of I. And I to the first power is I. And here's the one that's the most important. I to the second power is -1. And every once in a while you need these other ones too, depending upon who your teacher is. Any of you seen I cubes and I to the fourths? Yeah. So I cubed can be found, if you forget it, by basically saying it's I squared times I to the first. Therefore, it's -1 times I. Therefore, it's -1i, or -i. Anytime you needed it, you could always say, well, it's I squared times I squared. Therefore, it's 1, because it's -1 times -1, making it 1. Incidentally, if you needed any of the other ones above 4, it continues to cycle. I to the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, and it continues to cycle like that. So really and truly, we usually give you 2 or 3 questions on this standard, but if we wanted to, we could give you one problem. Because that one problem is going to have adding imaginary numbers, subtracting imaginary numbers, multiplying and dividing imaginary numbers. So, if you see a problem like this, 2 minus 3i over 5 plus 4i, you multiply by something called the conjugate, which is 5 minus 4i. This becomes a double FOIL problem, and in the numerator you have 2 times 5, 10, 2 times -4i minus 8i, -3 times 5 minus 15i, -3i times -4i, positive 12i squared. In the denominator, 5 times 5, 25. Outer, 5 times -4i minus 20i. Inner, positive 4 times 5 plus 20i. Last, positive 4i times -4i minus 16i squared. I keep running out of space on my paper. So now we combine our like terms. We have 10, a -5i and a -8i minus 23i. We have a plus 12i squared. I squared is defined as -1. Therefore, this basically becomes minus 12. Yes? So we have 10 minus 23i minus 12, which means we have what? I can't hear you. -2 minus 23i, that's our numerator. In our denominator, the outer and inner terms cancel. We have 25 minus 16i squared. I squared is -1. That makes it 25 what? Plus 16. 25 plus 16 is 41. Yes, yes, yes. So anytime they ask you to write a complex number on this essential standard, everything has a standard form to it. So whenever you write a complex number, we want to see it as a plus bi. So we can see what the a is and we can see what the b is. So right now we have -2 minus 23i over 41. So we're going to separate it to -2 over 41 minus 23 over 41i. Okay, and that is our final answer. If the 41 had been a 40 or something, we would reduce it. Okay, so can you add complex numbers? Can you subtract complex numbers? Can you multiply them? Can you divide them? One thing to point out, sometimes we like to give you something like this. 3 minus 4i squared, we will forget to FOIL it. And we'll think that the answer is something like 9 plus 16i squared. That's completely wrong. You've got to write it twice. 3 minus 4i, 3 minus 4i, now FOIL, 9 minus 12i minus 12i plus 16i squared. A teacher can tell that you haven't passed this standard if we look at your paper and we see an I squared on it. If we see an I squared on it, we don't have to look any further. We know you didn't pass the standard because you never leave an I squared. You always change an I squared into a -1. Okay? So this becomes plus 16i squared. I squared's -1, so it becomes minus 16. 9 minus 16 is -7. -7 minus 24i. Okay? The only other kind of problem they might give you is something like 3i times 2i minus 5 plus 8 times 4 plus I, or something like that. Now, all you're really being asked to do is what? Distribute and combine like terms. So you get 6i squared minus 15i plus 32 plus 8i. 6i squared, I squared is -1. 6i squared is -6. You have a -6 plus the 32, which gives you 26. You have a -15i plus 8i for a -7i. There is a reason why complex numbers are our first standard. It's basically the what? Easiest one. Does everybody understand complex numbers? Yes. The key is multiplying by a conjugate and remembering at all times I squared is -1.